So today is Chapter 12, Lesson 1, which is line plots. It says here for the warm-up, students in Mr. Cotter's class were asked how many after-school activities they have. Their responses are here in the table, in the chart here. So step 1 says use the data to complete the frequency table. This is a frequency table. Now when you do frequency tables, you're using tallies. You guys know what tallies are? You know, the little tally mark like this? Okay? Okay. And then the 5, you do the diagonal. Very good. So here is where we're going to put our tallies, and that's what yours should look like. Okay? Step 2 says turn the table so the number of activities is along the bottom on a number line. Instead of tally marks, we're going to place X's above the number line. The X's for 0 activities has already been placed for you. So when they say turn the number line, they turn the table, they just mean like that. So here you can see 1, 2, 3, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, right? And instead of the tally marks, we're going to put X's up there. Is everybody clear? All right. So here is what your line plot looks like. This display is called a line plot. Okay. Now, when you do your line plots, I want you to be sure that when you are putting your X's on the number line, does everybody see how the first row there is all lined up together? Yeah. And when you do the second row, it's all lined up. They're all lined up. So that way, if they're all lined up, that means that you would be able to just look at the display and pull out the data. Okay? If they're not that organized, if they're not that lined up, chances are, you could possibly choose the wrong mode. You might possibly choose the wrong median. So you need to make sure that your data, your X's line up. Okay? Here we're going to make a line plot. Please write this definition down. A line plot is a visual display of a distribution of data values where each data value is shown as a dot or other mark, usually an X, just like we had in our warm-up, above a number line. A line plot is also, it can be called a dot plot, but I'll usually call it a line plot, okay? All right, so this example you don't need to write down, just pay attention when I explain it. So it says Jasmine asked her class how many pets they had. The results are shown in the table. Make a line plot of the data, then describe the data presented in the graph. Now, look at this example. What are they missing that I would like for you to start with?
The table.
With the tallies, the frequency table, okay? So when you do your homework, I want you to start with a frequency chart. Is everybody clear?
Yeah.
Okay. So here they want to draw and label a number line. That's their first step. Then, and when you do your number line, you guys see this little star right here? It says include at least the lowest value and the highest value in the data list. Okay, you can go further than that, but you have to have at least the lowest and the highest numbers in the data list. Then we're going to place as many X's above the number line as there are responses for that number. And here is what the line plot looks like. And then after that, then we describe the data. Now, pay attention to how we are going to describe the data. So, describing the data, it says here, 24 students responded to the question. No one has more than 4 pets, and you can see that because the highest value is 4. Nothing goes beyond that. 4 students, here, 1, 2, 3, 4, see the 4 X's? 4 students have no pets. The response given most is 2 pets. So here, there's the most. You can see it's the most just by looking at the table because it has the highest tower there, right? So, if it occurs the most there, that is called the mode. All right, so for this example, this one I want you to write in your notes. Javier asked the members of his 4-H club how many projects they were taking. The results are shown in the table. Make a line plot of the data, then describe the data in a graph. Okay? So the first thing we want to do is we want to create our frequency table or a frequency chart. So what's the highest number? 5. What's the lowest number? 0. 0. So we're going to go from 0 to 5. Zero to 5. And now we just tally up the numbers, okay? So here we've got 2, 0, 1. So that's 2, 0, 1, 4, 5, 3, 4, 5, 3, 3, 4, 2, 3, 4, 2, 3, 2, 1, 3, 2, 1, and 1, 2, 2. 1, 2, and since this next one is a 5, it's going to go across like that. So there is our frequency table. Okay? Now, when you put the tallies as X's on the number line, when you make your number line, we also need to make sure that we include the title. Okay? You need to make sure you include the title. So our title is number of projects, and now we're going to put the X's on. Okay? So we've got for 0 projects, that's one person did 0 projects. 3 for 1, so there's 1, 2, 3. 5 for 2, that's 1, 2, 3, 4, 5. Let's see. 3 at 3 projects. 1, 2, 3. 2 at 4. And 1 for 5. So now we want to describe the data. Okay? I've already have it written out, and you can just take a look at it. Just like what we did in the first example. It said 15 members responded. Okay, 15 members responded. No one is taking more than 5 projects. Okay, because again, there's the highest, that's the higher upper extreme. 1 member is not taking any projects. That's taking 0 projects there. The response given the most is 2 projects. And that 2 projects represents the mode. So this is more analyzing line plots. You can describe a set of data using measures of center as well as measures of variability. The range of the data and any outliers are also useful in describing the data. Now when we're talking about the measures of center, of course, that's mean, median, mode, right? When we're talking about variability, that's range, then there's the interquartile range and then the outliers, right? That's the variability. All right, so for this first example, it says, our second and third example, it says the line plot shows the prices of cowboy hats. Okay, so here is our line plot. We want to find the median and the mode of the data, then describe the data using them. So here, when you look at this data, you can count the X's to see that there are 16 prices there. Okay, there's 16 prices. So when I find the median, that means that I have to count to the 8th number from the front and from the back, right? So that's good because 16 divided by 2 is 8. That's why we do that. So that's 1, 2, 3, 4, 5, 6, 7, 8. And there's the first middle number. And we've got 1, 2, 3, 4, 5, 6, 7, 8. And there's the second middle number. So 40 and 45 are the 2 middle numbers. when we find the median between those, when we add them and divide by 2, we end up with $42.50. That is the median. So what that median tells you, it splits the data in half, right? If it splits the data in half, that tells you that half of these cowboy hats cost more than $42.50, and half of this data, these cowboy hats, cost less than that. Is everybody clear?
Yeah.
Okay. Now we can look at the mode. The mode of this data is 50. And what that means for the mode, it means that that more of the cowboy hats cost $50 than any other price. So then we want to find the range and any outliers of the data, then describe the data using them. So here, same as we did up here, the range is the highest number minus the lowest number. In other words, what do we call those? You learned it yesterday in the Learn Bob? The extremes, right? It's the upper extreme and the lower extreme, okay? So we have 75 minus 30, that gives me 45. That is the range of the prices. The limits for the outlier are $12.50 and $72.50. So if we have data that's beyond those limits, then we have an outlier. And up here, you can see 75 is more than $72.50, so 75 is an outlier. So here we're going to do this example together. The line plot shows the number of magazines each member of the student council sold. Find the median, the mode, the range, and any outliers of the data. Then describe the data using them. Okay? So the first thing we want to do is we want to find the median. Well, let's see, how many numbers do we have together? There's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? So that means to get to the middle number, we want to count 7 from the back, from the front, and 7 from the back. So that's 1, 2, 3, 4, 5, 6, 7. So there's 1. And then we have 1, 2, 3, 4, 5, 6, 7. And there's the other one. So to find the median, we're going to add 20 plus 20. And then we're going to divide that by 2. Right. So that's 40 divided by 2, which is equal to 20. Good. The mode is the number that occurs the most. So which number occurs the most?
20.
20. We didn't have to show any work for that, right? And for the range, that's the highest number minus the lowest number. So we have 25 minus 17, and that's going to be equal to 8. Good. Okay. So there's your median, mode, and range. Okay, so now we're going to look at the outliers. Now, in order to find the outliers, we need the median and the quartiles, right? Yep. So we know we've already figured out the median. Let me erase this. So we found the median, and it's between those two 20s, right? Okay, so that's the median. Now, the x's over here, those are the lower half, and then here we have the upper half. So because we had, how many numbers altogether? So in order to get to the quartile 1, we're going to count 1, 2, 3, and then add 1. So there is your quartile 1, which is 20. Okay? Okay. To find quartile 3, we're going to count 1, 2, 3, and then add 1 more. So there is quartile 3. So to find the interquartile range, then, we're going to subtract the quartiles. Quartile 3 minus quartile 1. Now, I've already shown the work. So, oops, just so we can talk about it. Oh, that's not it. It's over here. Yeah, here it is. There it is. Okay, so this, to find the interquartile range, we're going to subtract quartile 3 minus quartile 1. And that's 23 minus 20, which gives us 3. Is everybody clear?
Yep.
Now we're going to find our B. Remember we just called it B because they didn't really have a name for it. So to find B, that is the one where we're going to multiply 1.5 times the interquartile range. Okay, so there's 1.5 times 3, which gives us 4.5. You guys writing this down? Good. Now we're going to use that value for B to figure out our lower limit and our upper limit. So to find the lower limit, we are subtracting quartile 1 minus the B. In order to find the upper limit, we have quartile 3 plus the B. Okay, so that's 20 minus 4.5. That gives us, okay, and 23 plus 4.5 gives us, very good. So those are the upper limit and the lower limit. So now we need to ask ourselves, do we have any numbers that are beyond those limits? So since we don't have any numbers beyond, then we have no outliers. Is everybody clear?
Yeah.
And then we want to describe the data using all of this information. So I've written it down for you.
Whoa. Do we have to show that on
All right, so there are 14 numbers represented in the line plot. This is just a description of the data. The median is 20. So half of the student council members sold more than or 20 or more magazines, and half sold 20 or less. Very good. The mode is 20, which means that more members sold 20 magazines than any other number of magazines. Pretty straightforward, right?
Yep.
And the range is 8. And there are no outliers. All right, so for this example, it says the line plot shows the amount James deposited in his savings account each month. We describe the data, include the measures of center and variability. So this is the same thing as what we just did in the previous example, okay? So we're just going to go ahead and do our got it. Okay? So here we have the line plot shows the prices of sweaters in a store. We want to describe the data and include the measures of center and variability. So the first thing for the measures of center, mean, median, mode, and range. Okay? So the mean, when we are adding these all together, can you see there's 4 25s here, right? So 4 times 25 is 100, right? Then this over here, these two x's count as 60 because there's 2 30s, right? Then we have 2 40s, that's 80. So that helps when we're adding up our numbers for our mean, right? So I've already added them up for you. So we have 350 divided by 10. And of course that's going to give us, yeah? $35. Very good. You just have to move the decimal, right? The median. Now, this is, let's see, 10 numbers. So the median, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. It's between the 2 30s, right? So, to find the median, we have 30 plus 30, which is 60. And of course, we're dividing by 2, and that gives us 30. Okay? The mode, we just have to look at it. What's the mode?
25.
Thank you, 25. The mode is the number that happens the most, right? The hint, it will have the highest tower. And the range. To find the range, we are going to subtract the highest number minus the lowest number, and that gives us 40. Very good. And these are all dollars, right? Those are all dollars. Okay, so there's the mean, median, mode, and range. Now, the next thing we want to do is we want to see if we have any outliers. So that's going through the measures of variability. So again, here's the work. All right, so the first thing we needed to do was we need to find the interquartile range. Now, remember, the median is between those two 30s, right? It's between those two 30s. So, quartile 1 is 1, 2, and then one more. There's quartile 1, 25. Quartile 3, 1, 2, and then one more. There's quartile 3. So to get the interquartile range, we're going to subtract 40 minus 25, which is 15. Then we'll find our B. So that's 1.5 times the interquartile range, which is 22.5. The next thing we're going to do is we'll find the lower limit and the upper limit. So that's the quartile 1 minus 22.5. And for the upper limit, that's quartile 3 plus the upper limit. Plus the B. Sorry. So look. So we want to see, do we have any values that go beyond the lower limit and the upper limit? And when you look at your data, we've got that 65 right there. So because 65 is beyond or greater than the upper limit, 62.5, then 65 is an outlier. So now we want to describe the data using that information. And pretty much when you describe the data, you're just summarizing what you have. Okay? So here there are 10 prices represented. The majority of the data is from 25 to 45. Okay? From 25 to 45. The median is the most representative of the data since there is an outlier, which is 65. The reason the mean would not be the most representative of the data is because that outlier brings the mean higher than it actually is. Okay? And that's all there is to it.